how much complexity can we squeeze out of a simple thing? Suppose that we don't want to just give a philosophical discourse in answer to this question, but a precise mathematical answer. How would we go about that? We might start by defining a simple machine, one which can just read in one piece of information from the world at a time. Let's say it has a tape with noughts and crosses on, and in each moment of time it can read whether it's seeing a nought or a cross. And it can only do very simple things as well. It can either write a nought or a cross, and it can tell the tape to move left or right. And it can also update its state. Its state tells it which rule to apply next if it sees a nought or a cross. And it can do one final thing, and that is halt, stop completely. And this machine, of course, is a Turing machine. It's really simple, but it can do everything that your computer can do. It can do everything that even a quantum computer can do, as long as you give it enough tape, enough time, and enough states. And it's very easy to make a machine like this run forever. You can just give it a rule which tells it always move right. But how do we squeeze complexity out of it? What does that look like? Well, it's something like giving it the set of rules, the set of states, which gets it to run for the maximum number of time before it finally halts. And this number of steps that it runs for is called the busy beaver number. And it's something like, it's telling us what the most complicated calculation that a machine of a particular size can run and still complete it. And this number scales with the number of states. So a Turing machine, which has just 2 states, has a busy beaver number of 6. If it has 3 states, it can continue for 21 steps before finally halting. If it has 4 states, it can go for 107 steps. If it has 5 states, it can go for 47 million odd steps. What about a simple 6-state Turing machine? Remember, this is a very simple machine still. How many steps could that run for before it finally halts? Well, we don't know for sure, but we do know that it's probably more than you could ever write down. In fact, it's almost certainly, it is more steps than can be written down in standard notation. If you wrote it down as 10 to the power n, the n that you'd need to use would itself be too large to write down. So it turns out that an enormous amount of complexity can be squeezed out of the very simplest of things.